So in this video I will talk about basic Python stuff. Basically I will be talking about lists, tuples, classes, functions, and what's the best way to use them in Python. So let's just get started with opening an IPython shell, and we will try out stuff there. So I will open an IPython shell here. So in Python there are basically three types of data structures uh, which are used to store a sequence of data. uh, those are the lists, the ticks, and the tuples. So lists are basically to store a sequence of arbitrary data. So lists are like regular containers which can contain any form of data. For example, this is a list which contains three numbers 1 to 3. This list can also contain a number, a string, and another number, and another list inside it. You can append to the list an element like this, in which case your list becomes the last element is appended, or you can even pop items from the list, which will basically give you the last element inserted into the list. Or you can access elements of a list using the square bracket notation like this. For example, here L1 will give me the first element of the list, and here we are counting from 0, so it will give me the string A. There are other operations in the list which are used to get sublists of this list. These operations are called slicing operations. So they basically give you a part of the original list which is there. So for example, if you wanna get the elements of the list from 0 to 4, you will simply write 0 to 4. So this is actually including the first number and excluding the last number. So it will give you 0th, 1st, 2nd, and 3rd element, not really the 4th element, right? And if you want to slice the list by stepping through not all the elements, but by jumping one step ahead, you could always specify a third variable like this: 0 to 4 colon 2. In this case, it will alternately jump between the elements and return you out. So in this case, 1, and then it will jump the A and give you 34. So these are kind of like basic operations you can do with lists. Lists are very powerful data structures in Python. So the basic building blocks of for loops, while loops can be expressed in terms of list. For example, if you have a list called L, which is composed of these four numbers, you can iterate through this list by doing this: for element in L, print element. So this construct is very important in list: for element in L, which is valid for any kind of sequence in Python, not necessarily a list. It works for tuples, it works for dictionaries. We'll talk about that later. So as you can see, it traverses through each element in L and prints it out like this. So suppose you wanted to print out the index of the element. There is a utility function called the range function, which basically gives you a list of elements from 0 to 4. So here range 4 will give me a list 0, 1, 2, 3, and if I print it, I will get 0, 1, 2, 3, right? So this is used to traverse through the index of a list. For example, for I in range of length of L. So now length of L is 4. So in this case, I represents the index of L. So I can do print I and the ith index. So you can see that 0th index is 5, first index is 6, second index is 7, and third index is 8. Okay. So these were the basic operations that you could do with a list. Another thing is that you can also do list comprehensions. So list comprehensions are very powerful way to compactly represent some complex expressions in Python. So for example, if you want to apply a particular function to a list, to all elements of a list, and store it as another list, there is a shortcut for that. It is called list comprehension. So suppose I have this list L again, which is 5, 6, 7, 8, and let's say I want to get a list which is a sign of all the terms in L. So let me name it as sign L. I will say sign of I for I in L. So but before that I need to import math for that. From math import sign, right? So one conventional way to do it is I will define sign L equal to an empty string. Then for I in range length of L, sign L dot append Li. This will basically append the sign of ith element of L to sign L. So in which case my sign L becomes this, right? But this is too much work, too much to type, and looks little clumsy at times. So there is a shortcut for that. So let's clean sign L again and see how we can do it using list comprehensions. So this is the syntax of list comprehension, which is nothing but the same syntax you use to generate a new empty list, and here you write the function which you want to apply to each element of the list, like this: sign of element for element in L. That's it. So what it will do is that it will traverse through each element in L and calculate the sign of that element. Of course, if you want to make it semantically equivalent to the for loop written here, you could write it as sign of L of I for I in range L, range length of L. Right, let's see what sign L looks like. Exactly the same as we got before, right? The good thing about list comprehensions is that it also supports basic type checking. So for example, you could have the sign L only for the even numbers and cos L if the index is odd. So you can do something like, so this will give you sin Li if I is divisible by 2, else cos Li. And the beauty of this is that this is almost like plain English. You could almost read it and you will know what this thing will do. I'm sorry. Mm, okay, somehow the else part is not working. I will get back to you on this. But the idea is that these are a powerful way to compactify for loops. But the thing is that this should not be overused, otherwise sometimes it becomes too difficult. So uh, what I mean is that a nested list comprehension is a big no, right? Okay, so with this I think the basic list stuff is done, and then maybe we can look at how dictionaries are defined in Python. So dictionaries are a way to store objects which have a key value kind of binding. So you have a key and an associated value. For example, let's define a dict D as this. So dictionaries are identified by curly braces, and let's say I have the key, which is the number, and the value, which is the name of the month corresponding to that number. Jan, oops. So basically the error was that March is not a variable. I should have defined a string for that and made these as numbers. Sorry about that. So this is a perfectly valid dictionary. Of course, just like lists, you can have any type for keys and any type for values. For example, you could have ABC and the value as any number. This also works. So this is also a generic container, but the use of dicts is to store values whose indices are not really numbers. The indices might be anything. For example, here the index is the string ABC, right? So the way to access a dictionary is exactly same as you would access a list. So D1 is Jan, D3 is March. If you do D2, which is now 2 is not a key in this dictionary, so it will give you a key error, which tells you that the dictionary doesn't have this key. So in order to check whether this has the key 2 or not, there's a method called has key, which applies on the dictionary. So if you call it, it will check whether this dictionary D has the key 2, and it says false. If I do has key 1, it says true, because there is a key entry named Jan corresponding to the key 1. So dictionaries are really fast, and they are really efficient to use when you have lots of data to fill in, because it only stores the data that is required. So if you don't have anything by the number 2, you could just get away with it and have the values only for the keys 1 and 3. So they are really efficient. If you want to traverse through a dictionary, there is a way to do that in Python, which is similar to the way we do with lists. So we will do for key in d.keys. Now d.keys is a function which will return all the keys corresponding to d. So let's print out the values of all the dictionaries, of the dictionary entries. So we will print out the key as well as the value corresponding to that key. So here you go. Similarly, there is a function called d.values. So it will print out all the values. Suppose you want to enter into a for loop where you would like to access the key as well as the value. There is another way to do this, where you can have key comma val in enumerate. So enumerate is kind of a special function which applies on a dictionary. So it will generate two lists, one a list of keys and another a list of values. So the variable key will traverse on the list keys, so d.keys, and the val will traverse on the list d.values. So key will be always the key of the current element, and val will be the value of the current element. You can check that using this, so you can match. I'm sorry, enumerate doesn't do that. You have to use d.iter items. Sorry about that. No, iter items is not an iterable, it's a function that I should call. Yeah, here you get it back. So the error we were getting here was that enumerate basically gives you two lists. One of them is nothing but an index list starting from 0 to the length of the sequence, and the other list is actually the the list which you are enumerating, the elements of that list. So that is why you are getting 0 1 2 3, which is the index list, and the elements of that list, which is by default the keys. But ideally, if you are dealing with dictionaries, you should be using d.iter items. Enumerate is especially helpful when you are using lists. For example, if you have l equal to 5 6 7 8, and you would want to access the index as well as the list value both at once, you would do for index comma value in enumerate L. Now if you will do print index comma value, this will give you 0 1 2 3, which is nothing but the index, and 5 6 7 8, which is nothing but the values. Alright. Okay, so now that we are done with basics of dictionary lists, this alright, just one more thing before we move on. The dictionaries can also be updated. For example, if you want to add a new key to this dictionary, you can do it like this. So if you see D now, it also has another entry for the 7th month. Note that the argument passed to the function update can be any dictionary. So you can have one entry or multiple entries. So you can have let's say 8th, which month is 8th? August, I believe, and then maybe 12, sorry about this, December. Okay, now let's see what happens to D. So it has all the months. What happens if you update an existing value? Suppose you say August. This should not do anything, which is as expected. It doesn't do anything because you already have an entry by the key 8. What if you change the value to that entry? Suppose I am an idiot, I do the 8th entry is November. What does it do? It simply updates the entry for the key 8. So update works whether you are attaching a new key or just modifying an existing key. So it's like an append to the list. But a fundamental difference between a list and a dict is that dicts are not ordered. So if you are expecting to go in a certain order, you should always use lists, because if you are printing a dictionary, printing the keys of a dictionary, you could never tell in which order the dictionary entries will come, right? So that's a fundamental difference. Okay, so the next thing should be tuples. Let's look at tuples. Okay, by the way, why do we need tuples? Tuples are what is called immutable immutable data structures. So what is mutable is what can be changed. For example, if you have a list 1 2 3, you can always append stuff here to make it bigger. But tuples are not like that. If you have a tuple T, which you define using normal brackets, it's 1 2 3, you cannot have append. See, there is no method called append for tuple object, has no attribute append. So basically, once it's defined, it's defined. So all the operations that happen on tuple, that happen on the lists, not many of them are available on tuples. But then tuples are fast. So other than that, you access tuples the same way as you access dictionaries. If you go out of index, of course it will give you an index error, because there is no third entry in the tuple. Of course, every time I say third, I'm counting from 0. So this is it for tuples for now. I think it is time we can move to functions. But then before that, let's take a break.